Unit 13, Day 7, Systems of Equations, Mixed Applications. Okay, so I want to make these problems as real as possible. Okay, so rather than just me working, I'm going to try, rather than me just saying, okay, the answer is C, or the answer is B, or the answer is whatever, I want to try to explain as well as I can where I get the answers to each one of these. Okay, because here's the reasoning, that a lot of these questions are EOC questions, or EOC's type questions that we've actually seen in the past. So we want to make sure that you understand why these are correct, why the correct answers are correct, why the incorrect answers are incorrect, that we can do the best in the future. Okay, so let's dive into this. Number one, Tremaine made a table below for the system of equations y equals 2x plus 1 and y equals negative 4x plus 1. Based on the table below, where is the point of intersection? Okay, so if you think about it, when two lines intersect, that means they're in the same place at the same time. So here, these are like our times, these are our places. Okay, so we are actually looking for these to have the same y value. For instance, I'm pointing right here, the same y value wherever the x is. So 0, 1, 1. That actually means that for this first line, it is at the place 0, 1. See the x and the y? And the second one, the x is 0 and the y is 1. So they're both at 0, 1 at the same time. So B is our correct answer. Okay. Number two, when using elimination to solve this system, what will be a possible first step? Elimination. So in our first step of elimination, we would need to have a zero pair, right? Okay. By the way, this is going to include substitution and elimination, okay, or graphing for that matter. It's going to be all over the place, okay? But zero pairs is what we're looking for. So look at our options and see, do any of these have zero pairs in them? And I want to just kind of point out something right here. This right here, they got x or y by itself. This is classic. That's classic substitution. Get x by itself. Not elimination so I don't care about it. How about C? Same thing actually. Okay, and D, classic substitution, they got y by itself. So it can't be any of those. This one, however, has a zero pair. So A is actually the only possible option that fits elimination at all. So look at this question. Was it a hard question? No, not at all. Okay, but what did it require of you? It required you to know what elimination was. That's it. Okay, so not a hard question, but we need to know why it's true. Okay, number three. Which graph shows the solution of the following system? Okay, we have y equals negative 1/2 x plus 1 and y equals negative 2/3 x plus 2. Okay, now before I start worrying about slopes and whatnot, and actually graphing these lines, you can type these in your calculator and you can see what they look like. Okay, that'd be probably the quickest way. But I want to use a little bit of common sense on this to eliminate some choices. Negative slope, back to my marker here, negative slope, negative slope. Two negative lines. Well, negative, 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 positive, 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 negative. We're already down to 2, okay, before I've even done anything. Now let's see. Now I can worry about these slopes, okay, and the y-intercept. So one of them has a y-intercept at 1, 0, 1. And so it should, let's see, so in this case it's that one right there. Now that line should have a slope of negative 2/3. Down to over 1, 2, 3. That looks doable. That's possible. Let's check this one out. Start at 1, go down 2, over 1, 2, 3. I don't think so for this one. Okay, so I'm leaning towards A. But to check that, let me just do this. I think it'd be fair to try to guess this one, or I say guess, to make that estimated guess. Let's see. So here is what that first line looks like. All right, so that's already looking kind of like A. But here's what the second one looks like. Negative 2/3 x plus 2. Here's what they look like together. So that is most definitely looking like A. So A it is. These lines on C, too steep. Okay. Number 4, which pair of equations corresponds to the two lines in the graph? Again, I could actually type these in the calculator, then clear my scratch pad, type these in, scratch pad, type these in, scratch pad, and just repeatedly do that. But let's use the common sense and what we know about lines to figure this out. So let's see. We have a positive. So this one is it -2 and has a positive slope. -2, positive slope. Okay. Check. I'm going to hold on to that one. Okay. The other one starts at -5. -5, and no, that is not the y-intercept of either one of those. That one's out. +5. So 1, 2, 3, 4, 5. We have we should have, so really our equation should have something that is a negative slope. By the way, I'm going to do this one first. So a negative slope +5. And for the second equation, it should be a positive slope -2. +5, -2, negative, positive. Okay. +5, -2. Oh, not negative. That should be a negative something or other. So not that one. -2 with a positive. No. Well, look at that. +5, negative slope. Now, again, let me graph these and just double check that since I have already determined the fate here. Just using common sense alone. Nothing too earth-shattering. -2x + 5. Okay, again, there's -2x + 5. There is 1/2 x -2. There are my two lines. Back up there, 2 lines, that's B. Use your brain. You got one and it works. Use it. Right? The EOC, honestly, I don't think at the end of the year is really that hard. If you pay attention and you use the brain that you got. If you spend your time guessing and trying to sleep through the test, it won't turn out too well. But I don't think it's that. You guys are all intelligent human beings. Okay, you can do it. It's just a matter of working towards that. All right, number 5. What is the intersection point of the lines 2x + y = 2 and -3x - 2y = -6? Okay. I don't have a particular method in mind for this, but I could get y by itself for them and graph the two equations. I could do that. I could actually try to solve this as a system. I could plug these points in and see if they come out, make both these equations true. That would probably be a good choice, actually. But I'm actually going to try to solve this. Okay, so let me just write this over here. I have -3x - 2y = -6. All right, so if I were trying to solve this, I need a zero pair. I would probably try elimination here. Okay, and I would probably go, let's multiply this by 2. All right, so let me write this down here. I'm going to get 2 times that, so 4x + 2y = 4, and -3x - 2y = -6. Those actually add together to be just 1x = -2. Well, take those two out. Now, if I had to make an educated guess, I could. I have x is -2. Now, let's go up here. 2x + y = 2. Well, if I plug in my x is -2, see, that gives me a -4 + y = 2. Add 4 to both sides. Y = 6. That is B. Okay. Okay. Number 6. Solve y equals 2/3 x - 1 and y equals -1/3 x + 2. Okay, now if I were going at this one, honestly, this one is made for graphing. It's just made for graphing. They're both y equals. That's probably the most prudent thing to do. All right. So you may not have a calculator at home. But if you do, by the way, the best website that I think I know of for graphing calculator at home, Desmos.com is really awesome as far as being a graphing calculator. So you can actually just tell it to graph. It'll even make tables and stuff for you. You can look at the intersection points and stuff. But I'm going to go ahead and do this, and I'll show you what my graph looks like once I graph it. 2/3 x minus 1 and negative 1/3 x plus 2. All right, so there, let me see, there's my graph. And if you notice, that is like, I don't know, like 3 and 1. 1, 2, 3, 3, 1 actually. There it is. Now, let me just do this. I'm going to show you, this is how I would algebraically check this if I were checking it, okay? Here's my x, here's my y. Let's see, so I plug that in, I get 1 equals 2/3 times x, which is 3, minus 1. Let's see, that's going to be 2. 2 minus 1 is 1. That one checks. Let's see, y is 1. Negative 1/3 times x, 3 plus 2. This would be negative 1. Negative 1 plus 2 is 1, which checks. Okay, they both turn out to be true. That's how I know that one works. I could do that on the calculator, and I could do that for each one of these points, and this is the only one that would come out to be true on both equations. Both equations. All right, let's check out 7. If you graph y equals 2x plus 1 and y equals x plus 1, okay, how many times will the two lines intersect? Okay, this is a really easy question. Don't let this one trick you at all. I'm not even going to graph them. I'm not going to graph them. I'm not going to use the calculator. I'm not going to do anything. Just going to use a little bit of common sense. Two lines. Two lines. How many times can they intersect? They can hit once. They can be parallel. Or they can be the exact same line, one line on top of the other. So we can have this is infinitely many. This is no solution. And this is one solution. So can't be 3. 3 is never a good answer here. There are places that it was a good answer in other classes and stuff, but for us, as of right now, that's never an answer. They actually can't hit twice. 0, 0, 1, or a bunch. And these two are not parallel. We have a slope of 2, slope of 1. This would be if they're parallel. So they have to hit once. It's the only option for us. All right, Sam visits the cookie store and spends a total of $6.40. Raisin cookies sell for 30 cents each, and chocolate chip cookies sell for 25 cents each. He buys 3 more raisin cookies than chocolate chip cookies. Which system of equations best represents the situation if C is the number of chocolate chip and R is the number of raisin cookies? Okay, so raisin cookies, 30 cents. Chocolate chip, 25 cents. So our R should have 0.3 in front of it. And 25 cents for the chocolate chip into C. And he spends $6.40. So not this one. 0.3R, 0.2. Okay, so far this one is in the running. 0.3R, 0.25C, 640. There's a problem with that. I'll come back to that one. 0.25C, 0.3R, 640. That one's in the running too. What's wrong with this one? Shouldn't take you very long to figure that out. Hint, it's this thing right here. We have $6.40. H is out. Okay, so G and J. Now we need to look for more information here. He buys, I'm going to grab this one. He buys 3 more raisin cookies than chocolate chip cookies. So that means the raisin is more. Raisin is 3 more than the chocolate chip. So this is actually our valid equation, which in this case, R equals C plus 3. That actually works. There we go. Number 9. Mrs. Rice purchased 12 boxes containing a total of 70 golf balls. She bought a combination of small boxes, each containing 3 balls, and large boxes, each containing 20 golf balls. Which system of equations will determine the number of small boxes S and the number of large boxes L that she bought? Well, here's some information. She bought 12 boxes. That means total between these two, she bought 12. We also know she got 70 golf balls total. And since the small boxes contain 3, large boxes contain 20, those are the 2 equations I should be looking for. Let's see. So 5S, yeah, 5S, S plus L is 12, okay. Possibly 20L, no, 20S. Small boxes can't contain 20 because the large boxes do that. So S plus L is 12, 3 for each small, 20 for each large, total of 70. Come back to that one. 12 SL, I don't know where that 12 came from right there. That one's out. That one was just ludicrous. Gotta make sure it makes sense. All right. Sally buys 12 tickets to the Fun Time Circus for a total of $58. If adult tickets cost $6 each, and each ticket for children costs $2.50, which system of equations best represents the situation? A is the number of adult tickets, and C is the number of children tickets. Okay. Now let's see. Let's first talk about this total right here. This is the amount of money they made that she paid. So she paid for adult tickets and children tickets. Children's tickets are $2.50. Adults are 6 each. So 6A, 2.5C is 58. 6A, 250C, 58. Hold on to that one. 6A, 250C, another decimal problem. That one's out. 6A, 250C is 58. Okay, so hold on to these two. All right, now we've got this other question. She buys 12 tickets. She buys 12 tickets. That's a total tickets. So that means A plus C is 12, which is D. Okay. Next, Julio is a taxi cab driver in the San Francisco Bay Area. Every time he takes a passenger out of San Francisco, he has to pay a toll at a bridge to get back into the city. The bridges that Julio always uses are the Bay Bridge, with a toll of $2, and the Golden Gate Bridge, with a toll of $3. If Julio spent $52 crossing into the city 20 times, how many times did he cross the Golden Gate Bridge? All right. Now, there are numerous ways to work this one out. I'm going to go with this. Here's the Golden Gate, right? This is saying how many times you cross the Golden Gate Bridge. That means the Bay Bridge, Golden Gate Bridge, Bay Bridge. That means he crossed 20 times. That means he crossed 16 times for that one, 12 for that one, 8 for that one, 5 for that one. All right. Golden Gate is $3 for each of those. Bay Bridge is $2 for each of those. So let's see. 12 bucks plus 32, $44. He spent 58, 52. Not that one. $24 for that one. By the way, I'm doing A, B, C, and D, working out them right here. 24 plus 2 times 12, 24, 48. Not that one. One of these ought to work. 12 times 3 is 36. 8 times 2 is 16. 40, 52. All right, let's come back to this one. And 45 is 10. 55, not that one, so it is C. Sum of two numbers is 45. The difference of the two numbers is 13. Find the smaller number. All right, so ordinarily I would go with this. Sum of two numbers is 45. The difference of the two numbers is 13. Use elimination, okay? But I can probably, because it's multiple choice, okay, I can use my head a little bit, okay? The sum of two numbers is 45, difference is 13. I could probably figure out what the other number is and then, find the difference. You know what? I think it's more straightforward to actually just do this. Just add these two together. 2x equals 58. X equals 29. One of the numbers is 29. The question is this the smaller one or the larger one? All right, so I'm going to go back up here, this equation, but instead of an x, I'm going to put a 29. So 29 plus y equals 45. Is this, in fact, the smaller number? Before I go ahead and select it over here, I want to make sure. So if you subtract those, let's see. I have a feeling that's 16. 45 minus 29, 16. All right, so one of the numbers is 16, one of them is 29, so we want the, which one? The smaller number. It's A. Probably the most common incorrect answer was D for that one. You can see why, hopefully. All right, let's look at 13. Okay, these are our last two. Johnny and Sue are playing at the park. Sue plays on the swing 20 minutes less than Johnny. Johnny swings 3 times longer than Sue. How long did Sue swing? All right, well, if this is how long did Sue swing, then here's Sue and here's Johnny. Notice there is no table for Johnny. Okay, well, let's see. Sue plays 20 minutes less than him. Oh, Johnny's 3 times longer, so this means he was on here 30. He was on here 36, 75, and 90. Okay, so see where I'm getting that from. Hang on just a second and just look at what I said. Johnny swings 3 times longer than Sue. So more or less, this times 3 gives you this one over here. Okay. Try to use my information a little bit. Okay, so next we want to know if Sue plays 20 minutes less than Johnny. Well, is that 20 minutes less? Actually, yes. 30 minus 10 is 20. 36 minus that is 24. 50 minutes and 60 minutes. So it does end up being F, actually. Okay. Now let me just write down the system of equations you would use for this. Probably say Sue is 20 less than Johnny, and Johnny swings 3 times longer than Sue. That'd probably be the equation you'd use. Where'd I get an R from? Times Sue. That's probably the system of equations you'd use to try to figure that out. Okay. Let's look at 14. In 1990, with the Texas Rangers, Nolan Ryan had a combined walk and strikeout total of 306. The number of strikeouts was 10 more than 3 times the number of walks. How many walks did Nolan give up in 1990? All right, so if I were going to write a system of equations for this, I would say he had a combined, let's say walks is X, strikeouts is Y, total of 306. And the number of strikeouts, Y, is 10 more, more than's a backwards word, 3 times the number of walks. This is what I would go with. I would use a system of equations to solve that. So let's go with that. Do you see a zero pair here anywhere? I don't. There's not a zero pair. Okay, so I could really force this to be elimination, but it makes more sense just to see. If you notice you have y by itself, let's use substitution. Substitution, wherever we see a y, plug in 3x plus 10. So my step 1 for substitution would be x plus y, which is 3x plus 10, equals 306. 306. All right, so that means we have 4x, kind of skipping ahead here, but 1x plus 3x. 4x plus 10 equals 306. Let's see, so we want 4x by itself, subtract 10. It's 296 equals 4x. Divide by 4. X equals 74. All right, so X was the total walkouts. They're not walkouts. Okay, strikeouts. So 74 is actually the number of walks, which is actually what we're being asked for. So we don't have to go any further. 74 walks. And there we have it.